In this last section of 7.1, we're going to be looking at naming binary molecular compounds. So binary, remember, means two. So we're going to have two different elements that we're going to be dealing with in these compounds. So first of all, I want to look at this situation here where we're going to be looking at a very specific binary molecular compound. So Jeff has been a professional athlete for over 10 years. For 7 years, he's been taking dihydrogen monoxide to increase his endurance. Jeff's now addicted, and without DHMO, dihydrogen monoxide, he'll die in 3 days. There is no cure for this. So there is a website that does look at DHMO. So if we look at that website, DHMO.org is dedicated to research, information about dihydrogen monoxide. And so I would encourage you to check this website out. We'll kind of look some of the things here. Environmental impact. So this talks about DHMO contributes to global warming and the greenhouse effect and is one of greenhouse gases. It is an enabling component of acid rain, causative agent in most instances of soil erosion. Lots of problems here with this DHMO. So recent masses have led to loss of life and destruction of property in California, Midwest, Philippines. Significant levels were found in the in Indian Ocean tsunami, Hurricane Katrina. On down, it looks about industrial dumping, all kinds of different things for this substance. Let's see. Dairy industry talks about a person breaking their silence about it, a cover up. So I would encourage you to maybe check this out, see what you think about it. It is linked to many of these diseases. It's detected in the body when these different diseases are occurring. So, just make yourself knowledgeable about substances around. So back to molecular compounds, so we can learn a little bit more about, some of these substances that are in our daily life. They're composed of covalently bonded units or molecules. We're going to be using the stock system of naming. And so the stock system is going to deal with with prefixes that are going to tell us how many of each atom we have. So a lot of you may be familiar with these prefixes from your math class, but if you're not, this is again something that you'll have to know for this chapter, so possibly write it down somewhere. But you will need to know octa means 8, tetra means 4, all of these different things. And so whatever the prefix is going to tell us how many of each atom we have. The less electronegative element will be listed first, and it only gets a prefix if it has more than one of that atom for the first element listed. The second element is going to get a prefix no matter how many we have, whether it's 1 or 7, and it will also end in IDE. And that IDE, remember, is going to indicate that we have 2 elements in that compound. If a prefix ends in an O or an A and it's added to an element that begins with a vowel, for example, tetra prefix would end in an A, and if we add it to oxygen, we're going to drop that O or A off of the prefix when we add it to the element with a vowel. So another example, mono ends in an O, and if we add that to oxygen, we would get monooxide. So we're going to drop that extra O off of the prefix and just have monoxide. Pentaoxygen becomes pentoxide. So here we're going to name the following. So the first element, there's a 1. So if it's a 1 on the first one, we don't put a prefix. So it's just sulfur. And there are 3 oxygens, so trioxide. Iodine, there's 1, so it's iodine, and then trichloride. P is phosphorus, and there's 1, and 5 bromines or bromides, phosphorus pentabromide, phosphorus pentafluoride, xenon tetrafluoride. And now the last one, if the toolbar goes away, nitrogen, and we have 2 of those. So now we will put a prefix because it's more than 1. So dinitrogen pentaoxide. So the penta for 5, we drop the A because it's combining with the oxygen, which begins with a vowel. So now, if we look at these, we're going to decide which one would be first. And so our carbon's going to be first. And on most of your worksheets and things, you want to figure out which one's going to be first. But dicarbon and tetrabromide. Trinitrogen dioxide. Sulfur is the one that would be first. So sulfur monocyanide, oxygen pentafluoride, and trichlorine monoxide. So back to Jeff, if we're looking at the dihydrogen monoxide, di means 2. So we would have 2 hydrogens, and mono is 1. So, and 1 oxygen. So dihydrogen monoxide is water. And so if we go back and we were to look at our website again, is water in the body for all of these? Yes. If we look at some of those environmental impacts, is water involved in global warming? Yes, there's water everywhere. Is it a component of acid rain? Yes, there has to be water for there to be rain. Causes soil erosion, high levels in nearly every creek, stream, pond, verified in ice samples taken from the Arctic and Antarctic. So if you weren't aware of your chemistry and how to name things, you might be someone that would give your money to this website. The last part of this section looks at acids and salts. We will spend a lot of time later on in chapters 15 and 16 looking at acids and salts in more depth. So in this chapter, we just really need to know kind of the basics. So an acid is going to give off an H+ ion. Typically, acids are going to be either binary acids, or it's going to be hydrogen and one other element, or it's going to be an oxy acid where it has hydrogen, oxygen, and then some third element. Naming acids, again, we will do that later on, but typically you're going to have hydrogen with some negative ion, so it would be hydrogen chloride here, that then becomes hydrochloric acid. So binary and oxy acids, it's going to be hydro, your root word, or your anion, your root of that, and then end in IC. So it's hydrogen and chlorine, it becomes hydrochloric acid. If it's hydrogen and fluorine, it becomes hydrofluoric acid. Oxyacids are going to depend on the name of the polyatomic ion that hydrogen's dealing with. And again, that's something we'll look at in later chapters. A salt is an ionic compound made of a cation and an anion from an acid. And that's really all you need to know about acids and salts in this chapter.